I'd like to walk you through typing math in typest. There's some nice features that typest has for typesetting mathematics, and for someone who is new to typest and has questions about how to do that, the objective of this video is to show you how to enter math, kind of how to do some alignments, equation numbering, referencing, and use some of the built-in functions. While the math environment is very involved in typest, this serves as an introduction. I imagine, over time, more features will roll out, more questions will appear, and I'm excited to show you how I use types to do mathematics, and hopefully this is useful. So let's start with an empty document. So I'm going to call this example 3. And the very first thing that I like to do in typest is I like to set the paper to be US letter. So whenever I'm typing anything, the first thing I want to do is just make sure that the paper size is right. That way, if I want to print it or display it, it's just the right paper size. And generally, I think the default is A4, but for my usage, I usually use letter. So typest has two forms of displaying mathematics. All right, and the two ways are inline and block. So the block form is also referred to as out of line. But this will be very clear shortly. But essentially, these two ways allow you to display mathematics in a paragraph or to break it apart and have its own equation numbers. So let's do an example. Let's do an example just to start. So in an example, let's do some text. So use a lorem function to generate some bulk text. And let's say I want to enter an equation in line between these two blocks of lorem. So what I would do is I use the dollar signs, and I could say f of x is equal to sine of x. And what that will do is you can see I've done it in line here. There's no spacing between the dollar signs. That's important. And in line and text, the mathematics is typeset. So that's really nice. You could almost, if you weren't paying attention, you wouldn't even know, but there is an equation there. So that is an example of doing inline. Okay, now let's do an example of block form. So to do a block form of, let's start with the same example of lorem. But this time I want to put the equation kind of in the center. So what I'm going to do is I'm going to put an equation inside here, inside the dollar signs. And you'll see that when I do this, the equation is not connected to the dollar signs. I could do it either way. I can do it with a space, right? Or I can do it on its own line, right? And I prefer this method because as I'm reading text, I'll see the equation appear and I'll know, oh, this is an equation that I didn't mean to be in the paragraph. I wanted it to be highlighted or separated from the rest of the text. And these are the two main forms of typesetting mathematics. What's lacking at this point, though, is a numbering convention and a way to refer to equations. So let's talk about numbering. So if you want to number an equation, right? First thing we have to do is say set math equation. And in the set rule, we're going to choose the way that the document formats equations, right? So I'm going to make sure that the numbering, I'm going to talk about numbering here, follows some convention. In this case, we have a string. So in the string, you need to provide an example of the way you want it to look. And use the number 1, right? It knows to look for the number 1. And so now whenever I do any equations following this set rule, it will number the equations accordingly. So let's just copy this formula from right above, same exact formula. And now I'm going to paste it. And now you can see in the document to the right, we can see that the number 1 now exists for that equation. So I'm going to get rid of this lorem afterwards because I want to highlight a few things. So let's say I want to refer to that equation. So in order to refer to the equation, I need a label. So in the label, I'm going to put in angle brackets, and I'm going to use the kebab case. That's when you have words separated by these hyphens. And we're going to call this periodic. So this is the first equation, so some periodic function, right? And then I'm going to say some text, so like a periodic function is seen in. And now that I have a label, I can use the @ sign, and a list of available labels appears. And the only one we have now is this equation. So I hit enter. And what's really nice is that equation number is 1, and it automatically places equation 1 after the equation. So that's very nice. So why would you do this? You could just hard code. Why not? You could hard code. But let's say, you went through peer review and you need to now put a new equation in, right? So maybe you need to put in, g of x equals tangent of x, something like this. Well, when you did that, when you put this new equation above, it shifts the equation numbers. And so now you need to refer to the appropriate equation. So what's really nice is typest is now handling the labels and the equations automatically, right? So this way you can modify your document, move things around, but whenever you're writing text and referring to equations, these references or these ways of tying your text to the equation are kept in place. So that's a really nice feature. Another couple things you might want to do is let's talk about the placement of the number. Okay, so sometimes you don't want the equation on the right because the template you're using needs the equation on the left, right? So I could see some templates requiring that, and so for that you use this thing called number align. So I came back to my set rule, and I put a comma, and so now it prompts me with a couple other options. So let's choose number align, so I can click that. And there's a whole bunch of options here, right? But so instead of it being aligned on the right, let's make it aligned on the left. And just like that, now the equations appear on the left. So some journals and conference papers may require in their template that the numbers appear on the left. Some require that they appear on the right. So this is just a nice feature to be able to quickly change the way that the equations are displayed. Okay, so now let's talk about equation alignment. So in LaTeX, if you have any experience with that, you would have to sometimes having multi-line equations, and you would want to display those equations in a way that was appealing. And so let's just say we have a multi-line equation. Let's do f of 1 is equal to ax plus bx plus c. We'll do a square here just so I can show you the superscript. And then let's do f2 is equal to square root of x squared plus y squared. And we'll do f3 is equal to a fraction. Let's do sine of x over cosine of x. Okay, so these are meant to be 3 separate equations. So what I want to do to ensure it is I'm going to do a line break on each one of these, so a line return, and that's that diagonal backslash. So you can see I've created this backslash, and the equation is no longer, the equal signs aren't really aligned, right? But they're all centered, and then this number is also centered. So one thing I might want to do, like if I was doing this in I was being very detail oriented, I would want to make sure all the equal signs lined up. So one thing I can do is use an alignment marker like the ampersand. So the ampersand is my alignment marker. And I place them before each equal sign. So what does that do? Well, the ampersand in this case is right aligning everything over here on the left hand side of the ampersand is being right aligned, and everything on the right hand side of it is being left aligned. And that ensures that these equal signs are all correct and in place. But what's interesting is that using these ampersands, it alternates the alignment. So right now, this ampersand, as we see it, these ampersands, the text on the left is right aligned and the text on the right is left aligned. But then when I use another ampersand, say I do that, well, now it's going to toggle. So now the text is going to be right aligned on the right hand side instead of left aligned. And you can see that. You see all the text is right aligned right here. You can do a double ampersand and that will flip it yet again over to left aligned, right? So this toggling of left and right occurs. Every ampersand toggles left and right alignment. And so what I wanted to show you was a way that you can align the equations in case you have a multi-line or a group of equations that need to stay together. Now, the other thing is this number is centered. Some people don't like it centered. Some people want it on the bottom. Well, in that case, you just change the number alignment to bottom, and it'll be on the last equation, okay? So that's another option. Or if you want the top, you can do it on the top, right? So there are multiple options there. So let me call this a group of equations. So I'm going to refer to them. So a group of equations that are interesting is seen in, and we're going to call it group equations. Now, maybe my template that I'm using doesn't want me to hard call out equation every time. And in that case, you can change the supplement. That's what we call the text in front of the number. So in that case, you change the supplement. And then in here, I'm going to do EQ period. And just like that, all the equations are going to be labeled EQ period and then the number. So this is very powerful. You could do this at the very top of your document if you wanted. I put it here because I wanted to highlight it not doing that here and then later doing it. But the idea here is you have a lot of power in this set rule, and then everything following it follows the set rule. So I can change this on the fly. Now, another thing with numbering is sometimes you want a non-labeled equation. So why would you want that? So some templates out there they will only want you to put an equation number for an equation that is labeled. Okay, so what does that mean? That means if I have a number, then that means somewhere in text I need to call it out. Some people have that philosophy. I generally don't have that philosophy, and that's because if someone is referencing my paper in the future, while I may not have thought it important enough to include the equation in my bulk of text, someone in the future may be reviewing my paper and they want to reference that equation. Having a number allows them to make that reference. So I tend to agree with every equation should have a number, so that way others can refer your equations. But some societies, when you publish the paper, they require that every number has a citation. So the way you would do without that, the way you would basically essentially fix that is you would have to use the math command. Okay, so let's look at that. So let's say let's do an equation here. Let's do f of x equals secant of x. Okay, so I'm not going to refer to this equation, but it has a number. So now I need to figure out a way to get rid of it. And let's do another one following it. Okay, and I'm going to do some lorem so that way it pushes this whole thing to the other page, right? Because I want to show you both at the same time. And maybe I'm just going to do this too. So that way, there we go. Okay, so the objective here is I'm going to reference 5, but I'm not going to reference 4. So I'm going to put a label on it, and we're going to call this we'll call it 1 secant, and reference at 1 secant. So I want to reference 5. But I need to take 4 away. So what do? Well, I can do this thing. I go hash math dot equation, and then in a block, I'm going to put the equation. I'm going to call it secant of x, f of x. But you see, look, it's left aligned, right? It's like it's text. We don't want that. So what we want to do is we want to force it in block mode, true. And that brings it into the middle, but it assigns a number. So I go to numbering and I make it false. Okay, and when I do that, or none, sorry, none. When I do that, the number goes away. So you see I have 2 equations here. One has a number and one doesn't. So I'm going to get rid of this equation. And so now I've got a block form equation with no number, and then if I just use the regular process that I've done for these out of line or block equations, right, it automatically gives a number. Now there's no way to reference this equation because it doesn't have a number, but this is just a way to accomplish that task. Okay. What else? Let's talk about alignment or accents. So in the math mode, you might want to emphasize some text in order to establish a notation or leverage a known notation. So this could be things like derivatives or vectors. So it could be many things, right? So there are a number of built-in commands, and I've actually got some text out here to the side that shows some of the examples. So I'm gonna just paste it real quick and I'll walk through it. So this is straight from the documentation on Typest webpage. So if you go to Typest webpage and you read on their documentation on equations, you're going to see examples of these. And so these are nice because these give you built-in readable ways of understanding how things are formatted. So let's do an example. So here we go. So in our example, let's do derivative. Let's do some dynamics. So dot of x equals f of x of t, y of t, u of t. I don't know. Let's do u of t, comma t. Okay, so this is a dynamic equation. Equations, dynamics. Okay, so this is saying the right-hand side is the time derivative of whatever's on the left side. If I had a system of equations, I could, probably have, y is equal to x is some g of, let's call this g of x of t, u of t, comma t. All right, so now I've got a system, I've got an output function that's some function of states and controls, and I have some state dynamics based on some states and controls in time. This is very commonplace for the area in which I work, but this is an idea of being able to quickly use dots, the dot notation. You can do double dots, triple dots, quad dots. They represent essentially, in this case, time derivatives. However you want to define them. There's other accents as well, and if you look at the documentation online, you'll probably see what it is you need. Another thing that I use quite often is powers and subscripts. So I think maybe a good way is calling it, I think if we look at the attach command. So in the attach command, it's an environment. So it's the attach environment allows for subscripts superscripts, overscripts, under, all over. Okay. So an example of the attach would be something like attach. And let's do an example here. Let's do, let's say I've got the pi function, right? Power or something. And I want the top to be, I don't know, let's just do something here. And then the bottom, we're going to do, let's do bottom is alpha. And we'll do the bottom left is going to be gamma. And then the bottom right is going to be epsilon. And then top right will be f of x. I don't know. We'll just call it f. Or top right will be, I don't know, h. And then we'll do top right, top left. What are we missing? Top, bottom, bottom left, bottom right, top right. Let's do top left. And we'll call that G. Okay, so we have a good amount of notation here. While the spacing isn't perfect, these things can be fixed simply with maybe an H command of like 1 EM or 0.1 EM, right? You can play with the spacing accordingly. And so, if it's not perfect, you might need to make adjustments. These things, these odds and irregularities will occur, and being able to adjust them is going to be nice using those H commands or V commands to adjust vertical or horizontal spacing. In general, this formatting and sizing and spacing is all constantly being updated by typest, but depending on your version that's used, you may need to hard code some of these spaces. Some other options may occur, like if I was doing an integral, which is nice, so like f of x equals integral from t0 to tf of g of t dt, right? It automatically knows that I need to place these subscript and superscript as the limits of the integral. Now, there's been some discussion on my last video and about how to properly format this D. I generally use upright. There may be better ways, but this is generally what I do. The spacing looks good to me, but some people prefer to have more spacing. That's okay. But for now, that's what I would do. I would also do probably an H of 0.5 EM or, something, small, 0.2 maybe. What that'll do is give you a little bit of space between the function and your time derivative. So, it's nice that types recognizes where those limits should be. I'd like to walk through the cancel function. So the cancel function is really nice if you were doing algebra. So if I was doing a lot of algebra and I wanted to highlight where things need to be canceled. So let's do A plus B equals B plus C, right? So I got something like this. Then my next equation could be something like cancel, or A plus cancel B equals cancel B plus C. And what's that saying is the B's cancel on either side of the equation. And then what I'm left with is A equals C. Well, in general, when I'm writing papers, if it's this simple, I might just skip. But, it just goes to show you there's a way to do that. There's a lot of control. So there's a lot of power that you have over essentially how the cancel is displayed. And so an example of the cancel function with more control is below. Okay, so this is an example I worked out. to prepare for the video. And what I have here is that there's a cancel function. Inside there's an argument. And then after that, there's a stroke argument. And in the stroke argument, I say make it blue and make it transparent by 60% and make it 2-point thick. And so this is nice if you were like, well, I've got to do two cancels at the same time. The red ones cancel with the red ones. The blue one cancels with the blue ones. So that's kind of a nice way to represent that. I'll be sharing this code, look below in the notes, and there'll be a link to the code so you can see this. Cases. So sometimes you have functions that are piecewise. So when functions are piecewise, you might say, oh, I want to do this if this is true, or this if this is true. So let's just work an example. So let's say f of x is equal to case. And so let's do it's 1, 2, 3, or 4. Okay. And so what I like to do is break this into individual lines. So that way I know that each one of these lines represents something that's going on. So with one, and I could say if. So we could say if x is less than 0. And I could say if 1 less than or equal to x less than 5. I don't know. I'm just going to do some quick examples here. 5 less than or equal to x less than 10, and if 10 less than or equal to x. There you go. So there you go. Okay, so now I've got a good readable on the left, and I've got something nice on the right. But what's missing here are some alignment markers. So the reason why the alignment markers don't make a difference right now is because the if commands all line up nicely because you have one character. But now if I do like sine of x and I do tan of x, well, let's just do log of x. And we do, I don't know, 1/2 plus, I don't know, let's pick another thing, e to the 3x. And maybe, 4, that's fine. So now in this example, look, all the ifs don't line up. So what do we know about alignment? We just throw some ampersands in. So ampersand, 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 and ampersand. And so now when you do this, all of the ifs line up. But I generally like to have a little more space. So I always do ampersand quad. And what that does is it just gives me four white spaces to the right just before. So that way it gives me a nice gap between what I have and what I want to display. So that's just a good example of how to use cases. Another thing you can do is change the delimiter. So I could say I want the delimiter, instead of being a brace, maybe I want the delimiter to be, I don't know, a parenthesis, right? So in that case, I just specify the delimiter to be a parenthesis, and there you go. You can do a vertical bar. You can do a square bracket. You could do many, many things. There are many options out there. So you have a lot of options, and there's even options online to show you how to flip it. So if you wanted this to be on the left and this to be on the right, there's a reverse option as well. But we don't need to go too far into deep into that to keep this video a little short. The next thing I want to talk about is matrices and vectors. So in general, so let's just say let M be in BB of R. So this is we'll get to Blackboard bold in a minute, but for now I'm just going to do this just so that way we can just so I can show you an example of a matrix and a vector. And let V be in BB of R of L. Okay. So what I'm saying now in this statement is I'm going to say M is a matrix and it's got n rows and m columns, and V is a vector and it has L rows. That's essentially what this, and the values are all real. That's essentially what these statements mean. So if I want to do that, let's do a quick example. So let's say m is equal to mat, and let's give it some numbers. Let's do 1, 2, 3, 2, 3, 4, 5, 6, 7, I don't know, just giving it numbers. Okay, so I've got a matrix. Another way to do this, so one thing I like to do when I do matrices, when I type my code, is I like to actually make the code look like the matrix itself. That way, when I'm reading the code, I know what I'm going to look for on the right. And then, like say the matrix is, okay, and then the vector is, and we'll do a vector. V equals vec. And let's do 1, what was it? I don't know. So in this case, I've got, L in this case is 4 because I've got 4 rows. N in this case is 3 because I've got 3 rows, and I have 4 columns, so M is 4 in this case. So essentially, oh yeah, I like to do this thing. Nothing that says I can't do that. So it's just nice. So that way I've got, actually, I like to have, sorry. I just want to have it lined up so that way when I read the document, it's what I have over here on the right. Now, some people don't like the parentheses. Maybe they want to have square brackets. So if you wanted that, you can call it a delim, D-E-L-I-M, and you say, I want a square bracket delimiter, and then there you go. The matrix has square bracket delimiters. Similarly, you could do that with vectors. You could say the delimiter is going to be a square bracket. And just like that, you've got a square bracket. So it just depends on what you prefer. And you can quickly code this up. It's very nice. There's more formatting that you can do in these. But I think for now, right, if you're a beginner and you just want to start typing math, I think this is a good point. If there's anything you want to go more in depth with, please leave a comment, and it'll force me to look up and learn too if I don't know how to do it. Another thing is sizes. So being able to control the size is important if you are restricted to space, okay? So let's say I've got a 6-page paper, okay? And the first time I wrote it, it was 8 pages. Well, you might have to remove some stuff, but you might be able to make some adjustments to save you some effort. And that might just be, changing the size of some equations. Now, certain journals and conference papers and templates force you to use their sizes, and others allow you a little more flexibility. So typest gives you 4 built-in sizes that you can play with. They are display, inline, script, and subscript. In these 4 sizes, you can see on the left, this is what the inline size looks like. And on the right, this is a comparison to the inline size. This is straight from types documentation. And that allows you essentially to see and compare them very quickly. Text, fonts, and formats. Another thing I'd like to show is, formatting. So there's a number of fonts that are built into typest. This kind of comes from latex a little with the AMS math functionality providing these sort of fonts. And that's really nice because, if I'm typing, I might want to emphasize some font, some math symbol. I mean, I've run out of math symbols. I need to create a new one. Maybe I just need to do a new font, and there you go, right? There's only so many letters in the alphabet. So, one thing to do is to use, let's just, the math default, let's just talk about that, is italics. So if I'm doing default math, A, B, B, C, C, right? It's going to be italic, okay? But, you know, if I'm in the middle of an equation and I want it to look like normal text, you can use the upright function. In which case, I'm just going to copy and paste this. And I want to use upright. And just like that, the text looks like it's normally formatted. There's another one, sans serif. So sans means without. And so it means without the serif. Serifs are like all the fancy filigree on the characters. So we just call it sans. And just like that, I've got the sans serif math. Now this is italics, right? But it's a sans serif math. Another one is monospaced. Let's do that. Let me just do this. Just make this another page. Well, if I really want to force it to be another page, I'll just go pound page break. What that'll do is force this to be another page. Okay. So in this case, I've got monospace fonts. This would be like if I'm doing code, you know, I might have an algorithm, you know, something of that nature. You can change the font quickly there. Fracture, I think that's what it's spelled, fracture. And fracture is like much more fancy. So this is like just another font, F-R-A-K, not Frank, frac. And then calligraphy. Trying to think if there's anything else I'm missing. Oh yeah, blackboard bold. Okay. And then I guess I just regular bold. Let's put it before it though. So I just have regular bold. So you can look how many fonts there are right here, just in all of this, in this text. Now you would say, well, what about the Greek letters, right? How do you do all the Greeks? So we could do this. So there's a whole bunch of Greek letters. I wrote so many here that, let me just get rid of these. Well, that's like upper and lowercase. That's nice. I'm going to just break it right here before lambda. Okay. And the Greek letters, I wonder if there's a bold version. Sometimes they do that. Sometimes it supports bold. We're exploring now. No, it doesn't support bold right off the bat. So anyways, that was a nice little experiment. But having all these different characters is really nice because then you can use them for different purposes based on whatever it is you're working on. And I think that's probably a good bulk of what it takes to get started typing in latex, or sorry, in typest. There's one more example that I do want to describe, which is like, you know, underbraces and stuff. So maybe I'll just do that real quick. So some other formatting. So let's say I've got a series of numbers, okay? And I want to emphasize them somehow, right? So explaining under an equation, right? So in this case, we would use the underbrace function where you put your content in here, and then what you want underneath sits here, okay? And this is really nice because if I have many things I want to show, you know, it gives you the ability. So let's say I've got two functions. Let's say I've got f of x and g of x, okay? And I know that I'm doing a proof, and I need to prove that this function, let's call it v, equal to f of x and g of x, is always less than or equal to 0. I don't know, something like this, right? I want to show this to be the case. Well, maybe I've already shown earlier that f of x is negative, right? And then under brace, I've shown that g of x is always positive, right? So then let me just do one thing here. Do an h of 0.1 em, right? So I can do that, and that'll show that essentially I've got these two functions multiplying by one another. Because of that, it's less than or equal to 0, something like this. And so this is nice, but see how it's all black? It could be hard maybe to differentiate. So I created this example which shows how to color them. So maybe I have some text I want under that's red or blue. Red making me think like heat, like it's positive, and cool, like blue cold, something like this. So, having that ability to do that. Now this is actually fairly complex, but let's walk right through it really quick. So the first thing I did is I used a text rule that everything in this bracket is going to be one color. It's going to be red. Okay. And so when I do that, when I call this all red, what I'm going to do is I'm going to say that the first thing is the underbrace. So the underbrace is going to be red. All the text is going to be red. But I want the text to be black. So then I force this inside to be black. And then over here, same thing. I force the text to be black. So that's what this is. So let me just sort of like organize this so that it's more readable, and then maybe you'll understand what I'm doing. So the first thing is I'm making everything in this bracket. So let's do this. So there's everything in the bracket, in the text bracket. And then I've got this underbrace function. So in there I've got the first argument is what's being in the beginning, and then everything afterwards is what's in the bottom. So in the bottom there's this positive, in the top it's this black text that says f of x da 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 da. This size of 150. This is the LR command. We didn't talk about that, but the LR command is a way of scaling parentheses accordingly. So I mess with the scale of the parentheses in the LR. I can go into that I think in another video, but there's a lot of documentation on this on Type's webpage. The next argument follows in the same way. But while I'm here, I might as well talk about LR. So LR basically says I'm going to do some parentheses. And it automatically will scale them appropriately for whatever is sitting inside. So in this case, it's the brackets or the parentheses that are left, right. But I can say size, and I can say they're 50% is their size. So, they're smaller now, or 150, really big, or, 200, double their size, right? So you can play a bit with whatever the sizes that you want to hit. And I just chose the size to be 150. So there you go. We talked a little bit about the LR command. So essentially, there's a good number of commands here. I mean, we've talked quite a lot about formatting of math, display size, matrices and vectors, cases, and some examples, some spacing issues, alignment issues, numbering issues. So hopefully you found this video useful, and I didn't go too fast. If there are questions about something, please leave it in the comments, or just comments. You're like, I don't like the way you did this. Maybe this is a better way. Others can read the comments and they would be happy to see what you've done. But I'll post the notes so that way you can access this code later. And really appreciate you watching this video. And thanks again. Bye.